Good morning, my YouTube viewers. It's Crystal here. I'm just here because I want to go over the Connect4 program with you. Basically, what I did was I was looking at the YouTube channels of Keith Galley, and so I was coding based upon the Connect4 code. Basically, I'm not able to do a study with me or a code with me because what he did was he has written this code in 4 videos, and he's gone back and forth from one piece of code to the next. And as a result of that, I had to write down the code for the first video, code it, and then correct all the errors, and then write down the code for the second video and code it, and then correct those errors as well. So what we're going to be talking about this morning is the first 2 videos. And so the first 2 videos don't have any graphics on them, but I suspect what's going to happen for the next videos is that I'm going to have to use another software package like Replit, because I don't think that Google Colab is going to work with Pygame. It may, I don't know, it may, but we'll just have to wait and see. So what I'm going to do now is I'm going to go over the code review with you for Connect4, and the reason why I have an interest in Connect4 is because there's a ConnectX on Kaggle, and ConnectX is based on Connect4, so I want to learn as much about Connect4 as I can so I can work on this competition question. So we know that we've got this from Keith Galley's channel, so you know I'm not plagiarizing in any way since I've told you where I've got this information. First thing you want to do is you want to install Pygame. We're not using Pygame in this tutorial or this code review, but we will be using it in upcoming code reviews, so that's why I put Pygame in there. And then after we have imported Pygame, then installed Pygame, what we're going to do is we're going to import libraries. So we're going to import NumPy as NP, Math, Pygame, and SYS. Those are the libraries that we're going to import at this time. So after we've imported our libraries, what we want to do is we want to define our variables. Row count is 6 and column count is 7 because Connect4 has 6 rows by 7 columns. Even is 0 and odd is 1. And then we define the function print board, and what happens when we define the function print board is the board flips, because when we were playing the game, all of the values were on the top, all the pieces were on the top instead of the bottom. So we use this function in NumPy called flip, and that flips it. Then what we want to do is we want to create the board. So we create a board using NumPy matrix of all zeros of 6 rows by 7 columns, and then we do the print board, which flips it, and then we return the board. So now what we do is we ask the question, is valid location? And as you can see, I misspelled location here, so I'm correcting it. So we create a function is valid location by board and column, and you return the board, which row count -1 and column equals 0. And I do believe that that is one of the mistakes that was made in the first 2 videos, and so I couldn't get the program to work because of the mistake. And what I did was I found his GitHub account, and then when I found his GitHub account, I found that it was supposed to be row count -1 instead of something else that he said that wasn't correct. So now what we do is we get next open row. So for our in range row count, if board R column equals 0, return R. Now we make the function drop piece, def drop piece. It takes board row column piece, and then it returns board row column equals piece. And now this is the main part of the program. Well, no, it's not. It's called winning move. And what this winning move does is it checks to see if the horizontal pieces are winning, and then it checks to see if the vertical pieces are winning, and then it checks to see if the diagonal pieces are winning, and then it checks to see if the diagonal pieces in the other direction are winning. And so if any of the criterion is met in this function, then it's winning, then it's a winner. And now we go to the main loop of the program. This is the main bit of the program. It says board equals create board, game over equals false, turn equals 0. And it says while not game over. And this is another mistake that had been made because at the very beginning, he said turn modulus 2. No, at the very end he said turn modulus 2, but it didn't work. I tried to get it to work, but it didn't work. So finally I had to change it. So if turn modulus 2 equals 0 is the first if, and LF if turn modulus 2 equals 1. So I think that's a mistake as well. It should be if turn modulo 2 equals 1, and then a turn modulus 2 equals 0. So I think that's a mistake. Let's just see what it says. And then, because we come over here to our code, so it's turn 1, so that's player 1. Turn 2, player 2. Player 1, turn 3. Player 2, turn 4. So I think, and then it said make player 1 selection for, it says player 1 wins, and then the next one is 7. So I think it's player 2. So I think I may have made a mistake there. And then what we'll do is we'll say, so this is the main bulk of the code. If turn modulo 2 equals 0, then it's going to be player 2. If turn modulo 2 equals 1, it's going to be player 1. Column equals input. Player 2 makes selection. Column equals int column. If is valid location, board column. Row equals get next open row, board column. Drop piece, board row, column 1. If winning, board move 2. So this has got to be 2. And this has got to be 1. Says drop piece 2, drop piece 1. So we split that. So we didn't have to do that. I think what I'm going to do, because it's going to mess it all up, Let's try it. It says player 2, make a selection. So that's why it says, because let's try it again. Let's see what happens. 1. So it said player 2 make a selection. So that didn't work out. Let me just look on my notebook where I wrote the code down. It says if current equals 0. So let's see what happens. And the next one he said, if let's try it again. Okay, player 1 make a selection 1. Player 2 make a selection 1. Okay, player 1 make a selection 2. Player 2 make a selection 2. Player 1 make a selection 3. Player 2 make a selection 3. Player 4 make a selection 4. And it says player 1 makes a selection 4, player 1 wins, congratulations. So that worked. Yay, that worked. So we had to do a lot of trial and error to get it to actually work, but we got it to work in the end. So this is the main body of the program. That's your main body. And then what it does is it does all this. And you can see that player 1 won. And then here are your functions. So you've got winning move. You've got is location, get next open row, drop piece. And you've got create board. And you've got print board, and then you've got the variables. So you've got all of the code that you need to actually be able to write this program for yourself if you want to. And it probably would be a good idea to write the program for yourself, because if you write the program for yourself, then you're going to learn it better than if you just copy and paste the program. So that concludes this code review. It comes with video 1 and 2 of Keith Galley's Connect4 code. And then I'm going to be working on 3 and 4 as well, but I have a feeling I'm going to have to do that on Replit. And the reason why is because I'm not sure that Google Colab is going to do the graphics with this. So this concludes the program. I hope that you got some benefit from the code review, even though I had to make modifications to it. And the reason why I had to make modifications to it is because the actual code that he gave in the videos had errors in it, and I had to try to find out where the errors were. So thank you so much for supporting my channel. If you like this video, please like, subscribe, and share, and I look forward to making the next program for you.